Hello, I have here question 3 on Specimen 2019 question. It's a mechanics 1 question, and I say here is momentum and impulse, but really it's a mix. So it's momentum and impulse, but you can see that you have some subat and some forces. So I'm going to show you how to get full marks in this question. You have a block A, mass 9 kilograms, released from rest from a point P, which is at a certain height. Above horizontal soft ground. I will tell you later what this means. The block falls and strikes another block B, mass 1.5 kilograms, which is on the ground vertically below P. So if we do a sketch of this, we have a block A, and I just draw in dots because they say that they are modeled as particles in a minute. So B is 1.5 kilograms, and this is the ground, and it's soft. That means that this particle here, or both together, can just go inside the ground. So imagine that is sand, for example, on a beach. Then the speed of A immediately before it strikes B is 7 meters per second. Blocks are modeled as particles. So you have this particle here falling freely under gravity from here to here, and then something else happened. But the first thing they ask us is this distance h, this height where A is regarding to the ground. So this h. And so this is something falling freely under gravity. This is calling for subat. So we are going to write what we have. Subat. And remember, when we are working with gravity, we are going to choose a positive direction. I'm going to choose downwards because it's how the particle is moving, but it doesn't matter. You just have to be consistent with what you choose. The distance, the displacement is going to be h, and it's going to be positive, it's downwards, and it's what we need to find. Initial velocity is released from rest. It says here. Yeah, so the initial velocity is 0. Final velocity is given, is the 7 meters per second. They say the speed of A immediately before it strikes B, which is in the ground, is 7. So this is 7. Acceleration is the gravity, 9.8. They don't tell us any different than 9.8, so we are using that, and we don't need the time. So the first thing we are going to do is to use a subat equation without time, which is this one. V squared is U squared plus 2AS. So V squared is 7 squared, U is 0, and then 2 times acceleration times h. That's what we need. For using the correct method and substituting correctly, you get the first mark. So this is your first mark here, out of the 2 of this part A. And sometimes in this type of questions, they give you 2 marks here, one for the method, everything like this, and the second for substituting correctly. But when you have 2 marks only, one will be for this part, so for using correct method and substitute well, and the second one will be for the answer. So when we find h is going to be 2.5 meters. And that's the first part of the question, and this is your second mark. So 2 marks so far. This is A. So we've done just A. And then B is a bit more complicated. See that you have 8 marks. So I'm going to show you what is happening. Immediately after the impact, the blocks move downwards together with the same speed, and both come to rest after sinking a vertical distance of 12 centimeters into the ground. So this one hits this one. Imagine this is sand, and then they go a bit inside the sand, the ground. Assuming the resistance offered by the ground has constant magnitude of R newtons, find that value. We are asking now about a force. So the sun or the ground is difficult to go across. So it's putting a resistance upwards, so the balls or the particles cannot go much farther. It's a force. And so that means we have velocities here somehow. We will have an acceleration, which will be deceleration. So we are going to use that deceleration to find that force. But to find the deceleration, we are going to see what is the initial speed because we know the final speed. The final speed is 0 because it stops, it comes to rest. We know the displacement is 12 centimeters. So if we know displacement, we can find acceleration. If we know the initial velocity and the final velocity. Final velocity is 0. Initial velocity is the one that we are going to find. This is a collision question. So we have, before collision, one particle A moving with an initial velocity 7 meters per second, and we have a particle B with an initial velocity 0, because the one that is in the ground is still. And then after collision, we have that both are together, and they are moving with a final velocity. We don't know that final velocity, but it's the velocity of both of them here when they start to go through the ground. We are going to find this final velocity here, because it's the initial velocity of the way that they go through the ground, through the sand or wherever is that. And it's a collision, so we can use conservation of momentum. So conservation of momentum, that means that M1, remember, U1 plus M2, U2, so momentum before collision is going to be momentum after collision. And this is your next mark, or the first mark of this section, the correct method. We are using conservation of momentum, and you should say, don't write only the equation, I would mention just conservation of momentum because it's just one line. And we are going to substitute. So M1 is 9 kilograms. Initial velocity of A is 0. Sorry, no, it's not 0. When it hits, it's 7. Yeah, so U1 is 7 times 7. And then this part is 0 because this one is 0. So this speed is 0. This velocity is going to be, they are moving both together. So M1 plus M2, which is 9 plus 1.5, 10.5, times the final velocity that they have both together, this B here. So from here, V is 6 meters per second. And we are going to use that. And this is a second mark for this part of the question. So they are not asking you this velocity, but you need to find it. Otherwise, you cannot do the rest of the question. So you have one more mark here. And now what happens? Both particles together are moving through the ground. And they are moving with initial velocity 6 and final velocity 0. So we can apply Subat to that bit. That way we will find the deceleration, and with the deceleration we can find the force. So displacement, they say it goes through the ground for 12 centimeters. Remember, we have to change everything to meters if we are going to use the gravity. So the initial velocity is, and because we need to be consistent with all the units, 6 meters per second, final velocity is 0. Acceleration is what we are going to find, and we don't need the time. So we are going to use a Subat equation without time, which is v u squared plus 1/2 a t squared. Sorry, I'm mixing equations. U squared plus 2as. Again, one mark for correct method. We are using Subat equation with that second part of the motion, so under the ground. When we substitute, we have v squared is 0, u squared is 6 squared, plus 2 times acceleration is what we need, and displacement is 0.12. And you see that the acceleration is negative, and it's minus 150 meters second square. And it's negative because it's deceleration. These particles are starting with velocity 6 and they are stopping. So the acceleration must be negative. Unless you consider negative down, that's fine. So this is another mark for finding this acceleration. But this is not what they're asking again. So they are asking the resistance force. So what is happening under the ground, I'm going to carry on here, is that you have your two particles together. They are moving down with a deceleration which is minus 150, and you have forces acting on them. So you have the weight of the particles, that would be 10.5 g, and the resistance force that they are asking us. So resistance force. So if we apply sum of forces, or resultant force is mass acceleration, we have that 10.5 g minus r, because they are moving downwards. So I'm going to write first this one. Is going to be mass, which is 10.5 kilograms, acceleration. This is 1 mark. To use this equation, you have 1 mark. And then we substitute, the only thing that we are missing is the acceleration. So 10.5 g minus r is 10.5. Acceleration is minus 150. And from here, we find that r is 1,680 newtons. You have 2 marks here. So in this first part of the question, so 1 mark if you substitute correct, but still you have 1 mistake, and the mistake could be, for example, the sign of the acceleration. And you have another mark if you substitute with everything correct. So when this equation, all these numbers are correct with correct sign, right? And the last mark you have is for the right answer at the end. So this answer here. So you see 1, 2, 3, 4 marks here, and another 4 marks here, for the 8 marks, and these 2 marks. Yeah. This is not super common question. So usually the collisions are just collisions, but this is a very interesting mix. Yeah, so don't discard. Every time they talk about distances or velocities, think that you can use SUVAT in questions that apparently are not constant acceleration or SUVAT equations. And this is it with this question.